Hello students, let us begin this session with the solutions to homework problems. First, if you get a job, then your credentials are good. Second, if it stays warm for a month, then the banana tree will bloom. Third, if the diagonals of a rectangle bisect each other, then it is a parallelogram. Fourth, if you get an A+ in the class, then you do all the exercises of the book. Now, let us look into contrapositive and converse statements. Contrapositive and converse are certain other statements which can be formed from the given statement with if then. For example, let us consider the following if then statement. If the physical environment changes, then the biological environment changes. Then the contrapositive of the statement, that is, if the biological environment does not change, then the physical environment does not change. Note that both these statements convey the same meaning. Write the contrapositive of the following statements. First, if a number is divisible by 9, then it is divisible by 3. Second, if you are born in India, then you are a citizen of India. Third, if a triangle is equilateral, then it is isosceles. Let us look into the solution. The contrapositive of these statements are, for the first one, if a number is not divisible by 3, then it is not divisible by 9. Second, if you are not a citizen of India, then you were not born in India. Third, if a triangle is not isosceles, then it is not equilateral. These examples show that contrapositive of the statement if P then Q is if minus Q then minus P. Next, I shall consider another term converse. The converse of a given statement if P then Q is if Q then P. For example, the converse of a statement P, if a number is divisible by 10, it is divisible by 5. Q, if a number is divisible by 5, then it is divisible by 10. Let us take up one more example. Write the converse of the following statement. First, if a number n is even, then n square is even. Second, if you do all the exercises in the book, you get an A grade in the class. Third, if two integers a and b are such that a is greater than b, then a minus b is always a positive integer. Now, let us look into the solution. The converse of these statements are, for the first one, if a number n square is even, then n is even. Second, if you get an A grade in the class, then you have done all the exercises of the book. Third, if two integers a and b are such that a minus b is always a positive integer, then a is greater than b. Now, let us look into if and only if statements. If and only if represented by the symbol means the following equivalent forms for the given statements P and Q. First, P if and only if Q. Second, Q if and only if P. Third, P is necessary and sufficient condition for Q and vice versa. Fourth, P is equivalent to Q. Let us take up one example to understand this. Here we have two pairs of statements. Combine these statements using if and only if. First, P. If a rectangle is a square, then all its four sides are equal. Q. If all the four sides of a rectangle are equal, then the rectangle is a square. Now, for the solution, a rectangle is a square if and only if all its four sides are equal. Let us see one more. P. If the sum of the digits of a number is divisible by 3, then the number is divisible by 3. Q. If a number is divisible by 3, then the sum of its digit is divisible by 3. For the solution, a number is divisible by 3 if and only if the sum of its digits is divisible by 3. Now, try to solve this. Write the contrapositive and converse of the following statements. First, if x is a prime number, then x is odd. Second, something is cold implies that it has low temperature. Third, x is an even number implies that x is divisible by 4. Let us look into this solution. First, contrapositive statement will be, if a number x is not odd, then x is not a prime number. The converse statement will be, if x is odd, then x is a prime number. In the second case, the contrapositive statement will be, if the temperature of something is not low, then it is not cold. The converse statement here will be, if something has low temperature, then it is cold. In the third case, the contrapositive statement will be, if x is not divisible by 4, then x is not an even number. Converse statement will be, if x is divisible by 4, then x is an even number. Now, students, let us recapitulate the concepts we have learned till now. First, a mathematically acceptable statement is a sentence which is either true or false. Second, explanation of the terms. First, negation of a statement P. If P denotes the statement, then the negation of P is denoted by not P. Compound statement and its related component statements. A statement is a compound statement if it is made up of two or more smaller statements. The smaller statements are called component statements. The role of and or in compound statement. The compound statement with and is true if all its component statements are true. The compound statement with and is false if any of its component statement is false. A compound statement with or is true when one or both the component statements are true. A compound statement with or is false when both the component statements are false. If one of the statement is true, then or is exclusive, and if both the statements are true, then or is inclusive. Next, we learnt that quantifiers are there exists and for every. Now, let us discuss what do you mean by validating statements. Here, we will discuss when a statement is true. To answer this question, one must answer all the following questions. What does the statement mean? What would it mean to say that this statement is true and when this statement is not true? The answer to these questions depend upon which of the special words and phrases and, or, and which of the implications if and only if, then, and which of the quantifiers for every, there exists appears in the given statement. Here we shall discuss some techniques to find when a statement is valid. We shall list some general rules for checking whether a statement is true or not. First rule says that if P and Q are mathematical statements, then in order to show that the statement P and Q is true, the following steps are followed. Step 1. Show that the statement P is true. Second step. Show that the statement Q is true. Rule 2 says that the statements with OR, if P and Q are mathematical statements, then in order to show that the statement P or Q is true, we should consider the following. Case 1. By assuming that P is false, show that Q must be true. Second case is, by assuming that Q is false, show that P must be true. So, students, today we studied about contrapositive and converse statements. We also introduced ourselves to validating the statements. We have discussed 2 rules in this. In the next section, we shall continue with some more rules. Thank you.